polynomials, okay? So the whole deal was that if we plug in the answer into the polynomial, it gives us 0 as an answer. So we're going to kind of build off of that today. We're going to talk about something called the fundamental theorem of algebra, okay? And what that says is that we can take the answers and we can build a polynomial if we know the answers, okay? If we know the answers, we can build the polynomial. So instead of having the polynomial and finding the answers, we're going to go the other way. So I noticed a few of the questions kind of asked you to put things in factored form and then solve from there. So let's look at number 7, okay, in your polynomial theorems. Let's look at number 7. All right, phones up, worksheets out, let's go. Okay, so if we know that 5, 0, 4, and -4 are our answers, let's kind of work backwards here. So what this is saying is x equals 5 is an answer. X equals 0 is an answer. X equals 4 is an answer, and x equals -4 is an answer. Well, where did these answers come from? If you think about the way we were solving them, we got it in factored form, and then we set our factors equal to 0. So let's kind of go backwards. Let's make these look like factors that are equal to 0. So if I want x equals 5 to be equal to 0, I'm going to subtract 5 from both sides. So I get x minus 5 equals 0. Okay, I get x minus 5 equals 0. If I solve that, I would add 5, so I get x equals positive 5. Okay. The second one, it's already equal to 0, so we don't have to do anything there. X equals 4, if we want that to look like a factor equal to 0, then we need to subtract 4 from both sides. So we get x minus 4 equals 4 minus 4 is 0. And then for the last one, to get that equal to 0, we need to add 4. So we get x plus 4 equals 0. So pretty much what happens every time is that our answer changes signs when we put it with an x. Okay, the answer changes signs when we put it with an x. Now, we've got to put all these together and end up with polynomials. So here's what we're going to do. We've got to multiply these all out. So this plain x by itself, I'm going to put that first. Okay, I'm going to list that first, and then I'm going to list the x minus 5, and then the x minus 4, and the x plus 4. Okay, now the reason why I do it in this order is because if you have something that's just kind of by itself like that x, you want that to be completely in the front. The second reason why I put the x plus 4 and the x minus 4 at the end, and I put them together because when I multiply that out, x plus 4 times x minus 4, that's the difference of perfect squares. So it's going to give me a smaller polynomial than if I multiplied x minus 5 times x minus 4. Okay, you're still going to get to the same answer. It's just being a little bit smarter about it. Okay, so that's what I'm going to do. I'm going to multiply x minus 4 times x plus 4. X times x is x squared. X times positive 4 is positive 4x. Negative 4 times x is negative 4x. Those cancel. And then negative 4 times positive 4 is negative 16. Next, let's see here. I've got a choice. Okay, I can decide how I want to multiply this out. Let's go ahead and multiply the x minus 5 by the x squared minus 16. Okay, we're going to have to FOIL that out too. So keep that x in front because we haven't done anything with it yet. Keep the x in front. Then we're going to distribute. X times x squared is x cubed. Be careful with that because usually when we multiply there we get x squared. But x times x squared is x cubed. X times negative 16, so negative 16x. Negative 5 times x squared, negative 5x squared. And negative 5 times negative 16 is negative 80, or positive 80, excuse me. Negative times a negative is a positive. 5 times 16 is 80. Okay, we don't have any like terms to combine right here. We've got x cubed, x squared, and a constant. There's nothing to combine like there normally is. So we're almost there. Last step, we've got to distribute the x. So x times x cubed is x to the 4th. I like it in standard form, so I'm going to go ahead and multiply the x times the negative 5x squared to get negative 5x cubed. And then x times negative 16x is negative 16x squared. And then finally, x times 80 is 80x. So that is the polynomial right there that has 5, 0, 4, and negative 4 as answers. Now, how can we check it? Just plug them back in. If those are indeed the answers, now I'm going to do it this way to save myself some time. I'm going to store my answer as x. So I'm checking 5, I'm going to store it as x, and then I'm going to type in my answer, x to the 4th minus 5x cubed, or excuse me, type in the polynomial, minus 16x squared plus 80x, and it should give me 0. It does, okay? Now, keyword here, given zeros. So that should be telling you if I plug it in, I get 0 as an answer. Let's test. Okay, tell me this. Just looking at it, if I plug in 0 for x, am I going to get 0 as the answer? Yeah, because all of these have x's in them. So if I'm multiplying everything by 0, and I'm adding and subtracting 0, I'm going to get 0. So I really don't need to check 0. If you really want to, you can, but you really don't have to. Okay, so let's check 4. Okay, remember to bring that up so I don't have to type it again. Second, enter, second, enter. Okay, there it is. Now I can press enter. I get 0. Store negative 4 as x. Second, enter, I get 0 again. Okay, so that means we did it correctly. When I plugged in those 4 zeros right there into the polynomial that I got from the answer, then I got 0 every time. All right, let's look at number 8. Okay, let's do another one like this. 0, negative 4, and 3. So if 0 is an answer, then we've got a factor of x. I told you that they change signs. So if negative 4 is a 0, then the factor is x plus 4. Kind of like, remember with synthetic division, okay, if we were dividing by x plus 4, we put negative 4 on the shelf. It's just going the other direction with it, okay? And if positive 3 is our 0, then x minus 3 is our factor. Obviously, this one's a little bit shorter to multiply out, right? We don't have as much stuff. Multiply x plus 4 times x minus 3, so x times x is x squared. X times negative 3x, I'm going to write this one out. Inside, positive 4 times x is positive 4x, positive 4 times negative 3, negative 12. So they're in the middle, just because I'm short on space, I'm just going to kind of do this in the same step here. Negative 3x plus 4x is plus x. So then if I distribute this x that's in front, x times x squared is x cubed, x times x is x squared, and x times negative 12 is negative 12x. So let's check that. Okay, obviously 0, if we plug in 0, all of them have x's, so we're going to end up with 0 as an answer. But let's do negative 4. This is another reason why I like to store it as x, because then you don't have to worry about the parentheses game. You just type in the equation exactly how it appears, and you don't have to worry about adding extra parentheses in there when they're negative numbers particularly. Okay, so negative 4 checks out. Let's check 3. Second enter. 3 checks out as well. 3 gives us 0 for an answer. Now, if we look at something like the ones that follow, 9, 10, we've got fractions, okay? 9 also has this idea of something called multiplicity. That's what that MULT stands for. It's multiplicity. All that is a fancy word of saying that that is an answer twice. Okay, that's an answer twice. Excuse me. So I could show you how to do this, but again, let's think about reality. Multiple choice test. So if they ask you a question like this, you're going to have answer choices. Okay, so I'm going to show you. Now your paper doesn't have the multiple choice choices on it, but mine does. So actually I'm going to shift that. No, I didn't mean to do that. Wrong button. Multiple choice. Nope, maybe I can't make a multiple choice. Yeah, there we go. Okay. There we go. Okay. So, number 9. Okay, if I have, it's the same question as yours, except yours just doesn't have multiple choice answer choices. So I've got to see which of these polynomials has these answers. So what was I just doing a second ago when I got my answer? What did I do? Plugged them in. So that's what you're going to do to decide which one works. Okay, you're going to plug them in. You're going to store 5 over 4 as x. Okay, and then you're just going to start with answer choice A. 32 x to the third minus 64 x squared plus 13x plus 25. And what are we looking for? 0. When I press enter, it should equal 0. If it does not equal 0, then that is not the answer. Okay? So A is not the right answer. So I'm going to press second enter because my answers look very similar, so I don't have to type everything in again. 32x cubed minus 64x squared plus 6x, so change the 13 to 6. Looking for 0. Don't have 0, so I got to do it again. Okay, the beginning's the same, then it says plus 16x. So second delete lets me stick a 1 in there. Okay, plus 16x plus 25. Still don't have 0, so let's check D. Okay, the beginning's the same, but it's plus 10x plus 25. Finally, I get 0, so that means that D is the answer to this. Okay, D, copy down that polynomial for number 9. Copy that one down on your paper. Now, something I do need to warn you about with this is it didn't happen in this problem, but say, for example, for B, I had gotten 0 when I plugged in 5 over 4. For B, I had gotten 0. I would still need to plug it into the other answer choices because they may give you more than one polynomial that has one of the zeros, but only one of them will have both or all of the zeros. Okay, so if for B 5/4 had worked, I'd want to keep checking my answer choices just to make sure that 5/4 didn't work for any of the other ones. Let's say that it worked for B and D. Well, then I would go in and I would check -1/2 in both B and D. It would only work in either B or D. Okay, so that's the one downside to just plugging in the answer choices. Excuse me, is you have to make sure, because they may try and get tricky, and put one of them that does have one of the answer choices. Okay, so let you practice with this idea on number 10. Okay, I want y'all to figure out on number 10, let me make this bigger so you can see it. Okay, on number 10, I want you to decide which one works. I didn't help too much, but